Hello! In this video, we are going to talk about Chapter 12, Decision Analysis. It turns out that there's a lot of different methods to help us make decisions. There's two different situations we can find ourselves in. One, where we can put a probability to some kind of future occurrence, and then another situation where we just can't put a probability to it. We're going to start by looking at the methods where we can't assign probabilities. One way to organize the information that we need is called a payoff table. It presents possible payoffs from different decisions that we might make, and it gives various states of nature. And this is an example from the book, a real estate example. In the future, there might be good economic conditions, there might be bad economic conditions. So those are the two possible states of nature in this example. Now we could have more than that. He could have put good economic conditions, fair economic conditions, and poor economic conditions, but he didn't. In this example, we just have two states of nature. And we've got three choices to make. We have an apartment building, an office building, and a warehouse. And these are the different decision-making criteria that we can use when we don't have probabilities. The Maximax Criterion is a shortcut for the maximum of the maximums. So we find the maximum payoff for each decision, and then we pick the maximum of those maximums. So in this case, the maximum payoff comes for the office building. We would choose the office building. The decision we're making is what kind of building to buy. We are not deciding whether there are good economic conditions or poor economic conditions. That is something that is out of our control. Teaching this course earlier, people kept saying, oh, well, I choose the good economic conditions. Well, yes, we would all love to be living in good economic conditions, but that's not under our control. That's something we don't know. That's something in the future. We are just deciding which building would be best to buy. So again, for Maximax, we would buy the office building. Another criterion is called the Maxi-Min. This is the maximum of all the minimums. If you are somebody who tends to be quite pessimistic, you might like this one better. Now we choose the maximum of all the minimums. So we find the minimum for each decision, and then we pick the maximum of the minimum. In this case, we would pick the apartment building because the maximum minimum is for the apartments. And a definition. Regret is the difference between the payoff from the best decision and all other decisions. And we calculate this separately for every state of nature. So for example, let's say I'm a pessimist and I think, okay, I'm going to buy the apartment building because that's what Minimax said. What if in the future it turned out there were actually good economic conditions? How much would I regret that decision? If there's good economic conditions, the best payoff is $100,000. I chose the apartment building. It's good economic conditions. I made $50,000, but I could have done better. So my regret is $100,000 minus $50,000. The regret for the warehouse is the $100,000 minus the $30,000 for the warehouse, or $70,000. And the regret for the office building is zero. No regret if I bought the office building. So what if instead of good economic conditions, it turns out that in the future we have bad economic conditions? What would our regret be? Well, under bad economic conditions, the best payoff was $30,000. So for the office building, I would take $30,000 minus negative $40,000, and that's $70,000. The regret for the warehouse is $30,000 minus $10,000, and then the regret for the apartment building is zero. If we did end up in bad economic conditions, I wouldn't have any regret about choosing the apartment building. So our third criterion that we're going to look at is called the Minimax Regret Criterion. The first step is to calculate all the regrets for each state of nature. And generally, we would put those in a table. Instead of a payoff table, then it's a regret table. And then we find the maximum regret for each decision alternative. And then we want to find the minimum of the maximums. So here's the regret table for that real estate example in the book. The maximum regret for the apartment buildings is $50,000. The maximum for the office building is $70,000. The maximum for the warehouse is $70,000. And I choose the minimum of those maximums. And so I choose $50,000. In this case, I would choose the apartment building. A very famous economist, whose last name I believe is pronounced Hurwicz, had an idea that would combine the Maximax and the Maximin criteria. He chose something he called the coefficient of optimism. He labeled that as alpha, and you get to decide how optimistic you want to be. So if you're pretty optimistic, you might choose that to be 80% optimistic, and your alpha would be 0.8. You're going to multiply the best payoff by that 0.8 and the worst payoff by 1 minus 0.8 or 0.2 for each decision, and then select the highest number, the best result. So our example again, in the book, he decided he was only 40% optimistic, so he picked an alpha of 0.4. So for the apartment building, he chose the best option, which was $50,000 times 0.4, plus the worst option of $30,000 times 0.6, which is 1 minus 0.4, and that comes out to be $38,000. And there are the numbers for the office building and the warehouse. And again, we want to pick the one with the highest number. So in this case, we would choose the apartment building. Our next criterion is called the equal likelihood criterion. It's a lot like the Hurwicz criterion, except we don't have to make a decision about how optimistic we are. We assume that all the states of nature are equally likely to happen, and so we just multiply the decision payoff by an equal weight. Essentially, this is just an average of the numbers we have for that decision in our payoff table. We have two decisions. They both get weighted 0.5. We take 50,000 times 0.5 and 30,000 times 0.5. We get $40,000. So in summary, for these methods without probabilities, most of the time we chose the apartment building, which might be a sign that we should buy the apartment building. Next, we'll go over some of these criteria that use probabilities. We're going to save some of these for class. If I have a pretty good idea what the probabilities would be for those different states of nature, I want to use them because that extra information can help me make better decisions. We're going to assume that the probability of a good economic condition in the future is 0.6, and that poor economic condition probability is 0.4. Now, where did these probabilities come from? Well, the textbook author just made them up. But we could do some research and see what these probabilities are, and that can help us make our decision. The first criterion is the expected value criterion, and the formula for this is just exactly what we learned in Chapter 11. We're going to take the payout amount times its probability and add them up. So we get a weighted average weighted by the probabilities. And then we want to choose the option with the highest expected value. So in this case, we would choose the office building. The next criterion is called the expected opportunity loss. This is the expected value of the regret table. So now I take the numbers in the regret table and use those same probabilities to compute an expected value. Only now we call it the expected opportunity loss. And because this is a loss, this is regret, we want to choose the smallest number. And so in this case, we would choose the office building. The next criterion is called the expected value of perfect information. To compute the EVPI, we first need to compute the expected value with perfect information. and it's not the same thing. So let's go through this example. If we knew exactly what was going to happen, we would choose the office building in good economic times and the apartment building if we knew bad economic times were coming. So we take the maximum payoff for each state of nature. That's our perfect information. And we compute an expected value for these numbers. So our expected value with perfect information is $100,000 times 0.6 plus $30,000 plus 0.4. We get $72,000. That's the expected value using that perfect information. Now we use this to compute the EVPI for each decision. With perfect information, the expected value is $72,000. Without perfect information, the expected value for that apartment building, we calculated this already, it's just there to remind you. We calculated that to be $42,000. So the EVPI for the apartment building is $72,000 minus $42,000, $30,000. If we could pay somebody $30,000 to give us perfect information, we could make $72,000 instead. But what if that person wanted to charge us $50,000 for perfect information? Well, and now it's not worth it. We have an idea of what additional information would be worth to us. And we calculate these for every decision. So I also have the EVPI for the office building. You see there it's $28,000. Note that this EVPI will equal the expected opportunity loss for the best decision. So for the decision that has the lowest expected opportunity loss, that number will be the same number as the EVPI for that decision. And there's the EVPI for the warehouse. Again, we start with the perfect information expected value, subtract the expected value for the warehouse to get the EVPI for the warehouse. The next one on the list is a decision tree criterion. A decision tree is just a diagram. Decision nodes are represented as squares. Probability nodes are circles. The decision alternatives are the branches or the arcs. And then we can compute an expected value at each of the probability nodes. So I'll show you what this looks like. Here's an example of that payoff table organized as a decision tree. And then the expected value is added at the probability nodes, the circles. And that first node is a decision node. What to purchase? Well, you would want to purchase the building with the highest expected value. As you have seen, there are a lot of different criteria for making a decision. And in class, we will look more at decision trees and we'll look at Bayesian analysis. Because if we have some extra information, some extra probabilities, we can use Bayesian analysis to help us make better decisions. But it's really hard to make decision trees on a computer. So we're going to do that in class on the whiteboard. And I will see you then.